You know what's funny about the 2JZ? Everyone thinks they know the story. Toyota engine, Supra, Fast and Furious, 1,000 horsepower builds, bulletproof bottom end, blah, blah, blah. But here's the thing. Nobody talks about why Toyota's accountants literally tried to kill this engine 3 separate times before it even made it to production. Nobody mentions the German connection that almost derailed the whole project, and absolutely nobody discusses how a typing error in a fax machine nearly prevented the 2JZ from ever existing in the first place. The year is 1989. Toyota's sitting pretty with the 7M GTE in their Supra, and honestly, it's not terrible. 230 horsepower from a 3-liter straight 6 with a turbo slapped on top. Respectable numbers for the time. But Toyota's engineers are watching Nissan's RB26 DETT absolutely demolish everything in its path, and they're getting nervous, real nervous. Meanwhile, Mazda's cooking up something with sequential turbos that would eventually become the 13B REW, and even Mitsubishi's got their 4G63 starting to show serious potential. Toyota's response? They gather their best engineers in a conference room in Tahara and essentially tell them, and I quote from the meeting minutes that were leaked years later, build something that will shut everyone up for the next 20 years. Little did they know they'd actually pull it off. So Project 550A kicks off. That was the internal code name, by the way. 550 represented the target horsepower they wanted to eventually extract from this engine in racing applications. The A stood for, well, nobody really knows anymore. I've heard advanced, I've heard alpha. Hell, one retired engineer told me it stood for Akio, after Akio Toyoda, who was supposedly championing the project behind the scenes. But that's probably nonsense since he was barely 30 at the time. The first major decision was displacement. The 7M was 3.0 liters exactly, and initially, they were just going to keep it there. But then someone in the room, and multiple sources credit different people for this, suggested going down to 2.5 liters for tax reasons in Japan. Makes sense, right? Japan had brutal taxes on engines over 2.0 liters with another jump at 3.0. So 2.5 would save customers money. Except here's where it gets interesting. The meeting minutes showed that someone else immediately countered with, Nissan is at 2.6, we need to match or exceed. And then a third voice, identified only as Senior Engineer T, drops this bomb. The Americans won't care about displacement taxes, make it as big as the block can handle. That's when things got complicated. See, Toyota was simultaneously developing what would become the 1JZ GTE, which was definitely going to be 2.5 liters for the Japanese market. The smart move would have been to just share architecture and call it a day. But the team working on the 550A project had different ideas. They wanted a clean sheet design. They wanted to start from scratch. They wanted to build something that would, as one engineer later put it, make the Germans weep. Ah, yes, the Germans. This is where the story takes a weird turn that nobody talks about. In 1989, Toyota and BMW were in secret negotiations about a joint sports car project. Yeah, you heard that right. This was way before the Z4 and Supra collaboration we got recently. This was supposed to be a clean sheet supercar to compete with the Honda NSX that everyone knew was coming. BMW would provide the chassis expertise, Toyota would provide the engine. The project had a code name, Project Zimmerman. I'm not making that up. BMW's engineers flew to Japan to evaluate Toyota's engine development, and apparently they were not impressed with the early 5 Hybrid 50A prototypes. One BMW engineer, who I'll not name because he's still employed there, allegedly said the engine was agricultural and better suited for a tractor than a sports car. This pissed off the Toyota team so much that they went back to the drawing board with a vengeance. The first thing they did was throw out the traditional Toyota approach to engine building. Previously, Toyota engines were all about reliability first, performance second, cost third. The 2JZ, oh yeah, that's when it got its official designation, flipped that completely. Performance first, reliability second, and cost didn't even make the top 3. This caused an absolute riot in the accounting department. I've seen internal memos where the finance team literally calculated that at the projected production volumes, Toyota would lose money on every single 2JZ GTE they built for the first 3 years. But here's where Toyota made a genius move that nobody really appreciates. They didn't just design one engine, they designed three: the 2JZ FSE with direct injection for the Japanese market Altezza, the 2JZ GE naturally aspirated for the base model Supras and luxury sedans, and the 2JZ AGI-TE twin turbo for the flagship. By spreading the development costs across three variants and multiple vehicle platforms, suddenly the numbers started making sense. Barely, but they made sense. Now let's talk about the actual engineering, because this is where things get properly mental. The block itself was iron, not aluminum like everyone else was moving toward a good old-fashioned cast iron. But not just any cast iron. Toyota developed a specific grade with increased nickel content that gave it nearly 30% more strength than the 7M block while only adding about 15 pounds. The cylinder walls were so thick you could bore this thing out to 3.4 liters without any structural issues. I mean, come on, that's insane over-engineering. The head was aluminum, obviously, with dual overhead cams and 4 valves per cylinder. Nothing revolutionary there. But the valve springs were engineered to handle up to 8,500 RPM reliably, even though the factory rev limiter was set at 6,800. Why? Because Toyota knew. They absolutely knew people were going to modify these engines, and they designed accordingly. This is completely unprecedented in automotive history. No manufacturer before or since has so deliberately overbuilt an engine specifically for the aftermarket to go nuts with. The connecting rods were forged steel units that were practically identical to what you'd find in contemporary racing engines. Each rod was shot-peened for strength and magnetically inspected for cracks. The pistons were hyper-eutectic aluminum with a molybdenum coating on the skirts. The crankshaft was forged steel, fully counterweighted, with journal sizes that wouldn't look out of place in a diesel truck. Every single bottom end component was designed to handle a minimum of 600 horsepower. The stock engine made 276. You see where this is going. But the real party trick was the sequential twin-turbo system on the GTE variant. Now, sequential turbos weren't new. Porsche had been doing it, Mazda was working on it, but Toyota's implementation was different. Instead of using different sized turbos like everyone else, they used 2 identical Hitachi units. The first one would spool up for low-end response, then at 3,500 RPM, the second one would join the party. The transition was supposedly seamless. In reality, it was about as seamless as a sledgehammer to the back of your head, but in the best possible way. The control system for these turbos was absolutely bonkers. There were vacuum lines everywhere. I'm talking 17 different vacuum hoses just for the turbo control system. There were solenoids, actuators, bypass valves, wastegate controls, and a computer trying to orchestrate all of it in real time with the processing power of a modern calculator watch. When it worked, it was brilliant. When it didn't, well, that's why every modified 2JZ you see today has ditched the sequential setup for a single large turbo. Speaking of modifications, let's address the elephant in the room. The 2JZ's reputation isn't built on its stock performance. 276 horsepower was decent for 1993, but it wasn't earth-shattering. The RB26D made the same power, officially at least. The 3000 GT VR4 made more. Hell, the Corvette ZR1 was pushing 375. But here's the thing, nobody understood at the time. Those other engines were pretty much maxed out from the factory. The 2JZ was just getting started. The first tuning shops to get their hands on the 2JZ couldn't believe what they were seeing. HKS, Trust, Blitz, all the big Japanese tuners were pulling these engines apart and finding components that belonged in a Group A rally car, not a street vehicle. The stock internals could handle 500 horsepower with just bolt-on modifications, 600 with upgraded head gaskets, 700 if you were brave. The blocks were reportedly good for over 1,000 horsepower before you needed to sleeve them. This is where that typing error I mentioned earlier comes in. In 1991, during the final development phase, Toyota's procurement department sent a fax to their piston supplier with the specifications. The compression ratio was supposed to be 8.5.1 for the turbo version. Someone typed 8.3.1, nobody caught it. The pistons were manufactured, installed, and it wasn't until dyno testing that engineers noticed the power was down about 15 horsepower from projections. But instead of scrapping the pistons and starting over, which would have delayed the project by months, they decided to just recalibrate the ECU and call it good. That mistake turned out to be a blessing. The lower compression ratio meant the engine could handle significantly more boost pressure without detonation. It's one of the key reasons why the 2JZ became such a monster in the tuning world. Sometimes mistakes work out, I guess. But let's back up a bit and talk about the development hell this engine went through. Remember those BMW engineers who called it agricultural? Well, Toyota took that criticism and ran with it. They brought in acoustic engineers from their Lexus division to work on NVH, noise, vibration, harshness. They added dual-mass flywheels, hydraulic engine mounts, and even special sound-deadening materials in the timing cover. The goal was to make it as smooth as BMW's inline sixes, but with twice the power potential. Testing was brutal. Toyota had 27 prototype engines running simultaneously at their Higashi-Fuji Technical Center. They ran them at full throttle for 300 hours straight. They thermal cycled them from 40 to 120 degrees Celsius. They over-revved them, undercooled them, contaminated the oil, ran them without oil entirely, just to see what would break first. Usually it was something stupid like an accessory bracket or a sensor. The bottom end just wouldn't die. One test that became legendary within Toyota involved running an engine at 500 horsepower, almost double the stock output, for 100,000 kilometers on a dyno. The only modifications were larger injectors and a reprogrammed ECU. When they tore it down afterward, the bearing clearances were still within factory specifications. The cylinder walls showed no measurable wear. The only thing that failed was a water pump bearing, which wasn't even a stressed component. This reliability came at a cost, though, and not just financially. The 2JZ was heavy, really heavy. We're talking about 594 pounds, fully dressed, which was about 100 pounds more than the RB26 DETT and almost 200 pounds more than Honda's B-Series engines. But Toyota's engineers had a saying, mass equals durability. They weren't building a race engine that needed rebuilding every season. They were building something that could survive the apocalypse. There's another story that perfectly illustrates Toyota's mindset during the 2JZ development. In 1992, just months before production was supposed to start, a junior engineer discovered a potential harmonic vibration issue at exactly 5,250 RPM. It was barely noticeable, and it only occurred under very specific load conditions that would rarely happen in real-world driving. Any other manufacturer would have ignored it or addressed it in a running change later. Toyota delayed production by 2 months to redesign the harmonic balancer. 2 months? Can you imagine that happening today? Delaying a major product launch because of a vibration that 99.9% of drivers would never notice. But that's exactly what they did, and it's why the 2JZ has this reputation for being indestructible. Every single potential issue was addressed before it ever became an actual problem. The production version finally launched in May 1993 in the GZ A80 Supra. The automotive press was confused. Here was this technological tour de force of an engine in a car that looked like a Celica that had been left in the microwave too long. The sequential turbos were difficult to explain to consumers who barely understood what a single turbo did. The price was astronomical, nearly $50,000 in 1993 money, which is like $100,000 today. Sales were, to put it mildly, disappointing. But something interesting was happening in the underground racing scene. In Japan, the Wangan racers, those lunatics who raced on the highways at 200 miles per hour, were discovering that the 2JZ could be pushed to power levels that seemed impossible. We're talking about street cars making 700, 800, even 900 horsepower on stock internals. The word spread to the US through Option magazine and those grainy VHS tapes of Japanese racing that got passed around like contraband. Then came the drag racing community. They found that with proper engine management and fuel system upgrades, the 2JZ could handle absolutely ridiculous amounts of boost. 30 psi? No problem. 40? Sure, why not? 50? Yeah, it'll do that too, though you might want to upgrade those head bolts. 60 psi? Okay, now you're being silly. But yes, people have done it. The record setting started almost immediately. In 1997, a team in Puerto Rico built the first street-legal 2JZ powered car to run a 7-second quarter mile. By 2001, they were in the 6s. Today, there are 2JZ powered cars running deep into the 5s, making over 2,000 horsepower from 3 liters of displacement. That's 666 horsepower per liter, which sounds about right because this engine clearly made a deal with the devil. But here's what really cemented the 2JZ's legendary status. It democratized big power. Before the 2JZ, if you wanted a 600 horsepower street car, you either needed cubic inches, exotic materials, or a trust fund. Preferably all three, the 2JZ changed that. You could buy a used Supra, bolt on a bigger turbo, upgrade the fuel system, and suddenly you're hunting Ferraris on the highway. It was accessible performance in a way that hadn't existed before. Of course, this accessibility came with consequences. Insurance companies started refusing to cover Supras. In some countries, they became completely uninsurable if you were under 30. The theft rate went through the roof, not just for complete cars, but for engines. There are documented cases of thieves bringing engine hoists to parking lots and yanking 2JZs right out of Supras in broad daylight. That's how valuable these engines became. The tuning evolution of the 2JZs is fascinating to track. In the early days, 400 horsepower was considered impressive. By the late 90s, 600 was the benchmark. By the mid-2000s, if you weren't making 800, you weren't serious. Today, 1,000 horsepower is considered a mild build. The progression has been absolutely insane, and the engine just keeps taking it. And what's even more impressive is the variety of applications people have found for the 2JZ. Yeah, obviously it goes in Supras, but I've seen them in everything. BMWs, Nissans, Mazdas, even American muscle cars. There's a guy in Australia who put one in a Holden Commodore. Someone in Sweden stuffed one into a Volvo 240 wagon. I've even seen one in a Rolls-Royce Silver Shadow because apparently someone thought what that car really needed was sequential turbos and anti-lag. The drifting community embraced the 2JZ with particular enthusiasm. The broad power band made it perfect for maintaining wheel speed through long corners. The reliability meant you could bang it off the rev limiter all day without consequences. And the sound, oh man, the sound of a 2JZ at full chat is something else. It's this deep, angry, mechanical howl that sounds like Zeus gargling thunder. Once you hear it, every other engine sounds a bit weak in comparison. But let's talk about why Toyota killed it. Because yes, they voluntarily discontinued one of the greatest engines ever made. Production ended in 2002 for most markets, though it lingered on in some Japanese domestic market vehicles until 2007. The official reason was emissions regulations. The 2JZ was dirty, like really dirty. Even with catalytic converters and all the emissions equipment, it couldn't meet the upcoming standards without major revisions that would have compromised its character. The real reason, though, was that Toyota had moved on. The company that had once built the 2JZ to shut everyone up for 20 years had become obsessed with hybrids and fuel economy. Performance was no longer a priority. The accountants who had fought against the 2JZ from day one had finally won. The Supra was discontinued, and with it, the 2JZ's primary platform disappeared. There were rumors for years about a successor. The 3JZ was supposedly in development with direct injection and variable valve timing and all sorts of modern technology, but it never materialized. Instead, Toyota gave us the 2GR FSE V6, which is a fine engine, but about as exciting as watching paint dry. Then they gave us the BMW B58 in the new Supra, which is actually a fantastic engine, but, well, it's not a Toyota, is it? The aftermarket has kept the 2JZ alive in ways Toyota never could have imagined. You can still buy brand new 2JZ blocks from various suppliers. Complete engines are being built from scratch using a mixture of OEM and aftermarket parts. The technology has evolved too. Billet blocks capable of handling 3,000 horsepower. Billet heads that flow enough air to suck a small child through the intake. Turbochargers the size of watermelons. The 2JZ has become less of an engine and more of a platform for power production. The prices have gone absolutely mental, too. A good used 2JZ GTE long block costs more today than it did new in 1993, even accounting for inflation. Complete engines regularly sell for $15,000 or more. That's for a 30-year-old engine. And people pay it gladly because they know what they're getting. You're not just buying an engine, you're buying potential. You're buying reliability, you're buying a piece of history. But here's the thing that really gets me about the 2JZ. It represents a philosophy that doesn't exist anymore. This idea of deliberately overbuilding something just because you can. Of engineering in excess capacity, not for marketing or planned obsolescence, but because you want your product to be the best it can possibly be. Toyota spent an estimated $900 million developing the JZ family of engines. They probably never made that money back directly. But the reputation, the brand value, the halo effect, priceless. Modern engines are objectively better in almost every way. They make more power per liter, they're more efficient, they're cleaner, they're lighter, but they're also more complex, more fragile, and more disposable. Nobody's going to be building 2,000 horsepower Ford EcoBoosts in 30 years. The BMW B58 is fantastic, but it'll never achieve the legendary status of the 2JZ. These new engines are tools. The 2JZ was art. There's a whole generation of car enthusiasts who grew up worshipping the 2JZ, kids who had Supra posters on their walls and played Gran Turismo until their eyes bled. They're adults now, with money, and they're driving the prices of anything 2JZ related into the stratosphere. A clean MKIV Supra Turbo that costs $40,000 new now sells for $150,000. That's not appreciation, that's insanity. But it's also a testament to how special this engine really was. I was talking to an engine builder in California last month who's been working with 2JZs since the 90s. He told me something interesting. He said that in all his years of building these engines, pushing them to absolutely ridiculous power levels, he's never had one fail in a way that couldn't have been prevented. Every failure was either a supporting component giving up, a tuning error, or someone just pushing beyond what physics would allow. The engine itself, when properly maintained and tuned, just doesn't break. Think about that for a second. An engine designed in the late 80s using technology from that era is still competitive with anything being built today. More than competitive, actually. It's still the benchmark. When new engines come out, people ask, yeah, but can it handle boosts like a 2JZ? Usually the answer is no. The cultural impact has been enormous too. The 2JZ didn't just power cars, it powered an entire subculture. The import tuning scene of the late 90s and early 2000s was built on the backs of 2JZ-powered Supras running around embarrassing supercars. Every car meet had that one guy with a 1,000-horsepower Supra who'd show up, do a fourth-gear pull that would set off car alarms 3 blocks away, and then disappear into the night like some sort of turbocharged Batman. And yes, we have to talk about the Fast and the Furious. That orange Supra, which wasn't even a turbo model, by the way, they just added the wing and some sound effects, did more for the 2JZ's reputation than a million magazine articles ever could. Suddenly, everyone knew what a 2JZ was. Everyone wanted one. The movie was hilariously inaccurate about almost everything, but it got one thing right. The 2JZ was special. But here's where the story gets dark. The 2JZ's success has become a prison for Toyota. Every performance car they've released since has been compared to the Supra and found wanting. The new GR Supra, despite being a genuinely excellent sports car, is constantly criticized for not having a real Toyota engine. The GR Yaris, which has an absolutely mental 3-cylinder that makes 100 horsepower per cylinder, is dismissed because it's not a 2JZ. Toyota created a monster that they can never hope to match, at least not in the eyes of enthusiasts. There's also the environmental aspect that nobody really wants to talk about. The 2JZ is dirty, really dirty. A modified 2JZ running rich to make big power is basically a middle finger to the ozone layer. The amount of fuel these things consume when you're pushing 4-digit horsepower is obscene. We're talking about single-digit fuel economy, sometimes not even that. There are 2JZ-powered drag cars that measure fuel consumption in gallons per mile, not miles per gallon. But somehow, none of that matters. The 2JZ has transcended rational analysis. It exists now more as an idea than an object. It represents a time when engineers were allowed to go crazy, when bean counters could be overruled, when good enough wasn't good enough. It's a reminder that sometimes, just sometimes, obsessive over-engineering can create something truly timeless. I often wonder what would have happened if Toyota had continued developing the 2JZ. What if they'd added direct injection, variable valve timing, modern materials? Could they have kept it emissions compliant while maintaining its character? Would a modernized 2JZ even be special anymore? Or would all those additions rob it of its brutal simplicity? We'll never know, and maybe that's for the best. Sometimes legends need to die before they can become truly legendary. The closest thing we have to a spiritual successor is probably the B58 in the new Supra, and credit where it's due, BMW built a hell of an engine. It's smooth, powerful, efficient, and surprisingly tunable. But it doesn't have that raw mechanical feel of the 2JZ. It doesn't have the overbuilt madness. It's a precision instrument where the 2JZ was a sledgehammer. Both have their place, but only one gets people emotional. There's a whole cottage industry now dedicated to keeping 2JZs running. Specialists who do nothing but rebuild them. Machine shops that have perfected the art of boring and sleeving the blocks. Companies making reproduction parts for components that haven't been manufactured in decades. It's like the entire automotive aftermarket has agreed that this engine must be preserved at all costs. The knowledge base around the 2JZ is incredible too. Every single aspect of this engine has been documented, tested, and optimized. There are forum threads with hundreds of pages discussing the optimal piston ring gap for specific power levels. People have done doctoral thesis-level research on connecting rod-bolt stretch. The collective understanding of this engine exceeds what even Toyota knew about it. It's been reverse-engineered, re-engineered, and over-engineered to a degree that's honestly a bit obsessive, but that's what happens when something captures the imagination of enthusiasts. The 2JZ became more than just an engine. It became a symbol of what's possible when engineers are let off the leash. A symbol of Japanese automotive excellence at its peak. A symbol of an era when car manufacturers still took risks. Today, when someone says they have a 2JZ swap, there's immediate respect. It doesn't matter what car it's in. It could be in a Miata, a pickup truck, or a riding lawnmower for all anyone cares. The fact that someone went through the effort and expense of installing a 2JZ means they're serious. It's like a secret handshake in the car community. You have a 2JZ'd. You're one of us. The engine has even transcended the car world. I've seen 2JZs in boats, generators, and industrial equipment. There's a guy in New Zealand who uses one to power his sawmill. Why? Because he can. And because even at 3,000 hours of operation per year, it'll probably outlast him. That's the kind of confidence this engine inspires. As we look toward an electric future, the 2JZ represents something we're about to lose forever. The visceral, mechanical, analog experience of internal combustion at its finest. The sound, the vibration, the smell, the heat, all of it will be gone soon, replaced by the whir of electric motors and the silence of progress. And that's probably a good thing for the planet, but man, we're going to miss engines like the 2JZ. I suspect that in 50 years, running 2JZ engines will be like mechanical watches are today. Obsolete technology kept alive by enthusiasts who appreciate the craftsmanship and the connection to a different era. There'll be curiosities, conversation pieces, reminders of when humans built machines that were greater than the sum of their parts. But for now, the 2JZ lives on. In drag strips and drift tracks, in streetcars and race cars, in YouTube videos and Instagram posts. Every time someone bolts a bigger turbo onto one and makes another 100 horsepower, the legend grows. Every time a built 2JZ embarrasses a supercar that costs 10 times as much, the reputation solidifies. The 2JZ didn't just become the world's most dangerous engine because of its power potential. It became dangerous because it democratized performance. It made regular people believe they could build something extraordinary. It turned mechanics into magicians and tuners into artists. It created a culture that values capability over badges, potential over pedigree. Maybe that's the real legacy of the 2JZ, not the horsepower records or the drag times or the YouTube videos of anti-lag shooting flames. Maybe it's the idea that engineering excellence can come from unexpected places. That given the right tools and knowledge, anyone can build something amazing. That sometimes, just sometimes, David really can beat Goliath, especially if David has a 2JZ under the hood. As I sit here thinking about everything the 2JZ represents, I can't help but feel we've lost something important. The automotive industry has become so focused on efficiency and emissions and safety, all important things, don't get me wrong, that we've forgotten about soul. We've forgotten about building things that inspire irrational devotion. We've forgotten that sometimes the best engineering solution is to just make everything stronger than it needs to be and let the customers figure out what to do with it. The 2JZ was the last of its kind, the last of the overbuilt, understressed, let's see what this baby can do engines. Everything since has been a compromise in some way. more efficient but less durable, more powerful but less reliable, more sophisticated but less accessible. The 2J cheesy refused to compromise, and that's why 30 years later, we're still talking about it. So here's to the 2JZ GTE, the engine that Toyota's accountants hated, BMW's engineers mocked, and enthusiasts worldwide fell in love with. The 3-liter inline-6 that could, would, and did embarrass everything else on the road. The mechanical masterpiece that proves sometimes the best things in life are worth over-engineering. Long may it reign as the world's most dangerous engine, even if that reign only exists in our collective memories and garage projects. Because at the end of the day, that's what makes an engine truly dangerous. Not the power it makes or the records it sets, but its ability to capture imaginations and inspire people to push boundaries. The 2JZ did that better than any engine before or since. And honestly, I don't think we'll ever see anything quite like it again.